that prove that a raised to log x to the base a is equal to x. That we need to prove here. What we will do, we will start with giving these names. This side of sign equal to is LHS and this is RHS. So what we need to prove that this LHS left hand side is equal to right hand side. Let's assume that our LHS is equal to y. That means y is equal to our LHS, which is equal to a to the a raised to log x to the base a. Okay, so we have assumed this LHS as equal to y. What we really need to prove that if a is a number whose exponent is log x to the base a, when these two numbers are same, the answer would be this number x. Now we have given names LHS and RHS to these two sides. We have assumed this LHS as another number, let's say y is equal to a to the base log a raised to log x to the base a. Now we need to bring this exponent here in the product with a, and for that we will take log on both the sides. Logarithm function on both the sides. So we will come to the step that log y is equal to log of log a raised to log x to the base a, means log of y and log of a raised to log x to the base a. Now we'll take log of this base of this log as a itself. Okay, so log y to the base a is equal to log of a raised to log x to the base a. By doing so, we'll come to the step that log y to the base a is equal to what? It is equal to log of a raised to log x to the base a. Okay, so next step would be log y to the base a, and now if it is log, then we can take this exponent in the product in the multiplication. So this exponent number, this index number would be taken here in the multiplication, and here we will be left with log a to the base a. This part will be our number and this is the exponent, it will come in the multiplication. So what would be the next step? It would be log y to the base a would be log x to the base a. Now this is what? This term will become 1. Why 1? Because it is a basic rule of log that log, let me explain here, log x to the base x is always equal to 1. When these two numbers are same, the domain and the base both are same, for any log term, it answer is 1. Because from the very definition rule of log, suppose if you are saying that x to the base x raised to y is equal to z, then by definition of log, what you write? You write that log of z to the base x is equal to y. In the same way, suppose 5 raised to 1 is always equal to 5. Why? Okay. So by definition of log, log of 5 to the base 5 is always equal to 1. So same way, log of a to the base a is always equal to 1, because when the domain and the base are same, by definition of log we can say that it is equal to 1. So the ultimate next step would be log y to the base a is equal to log x to the base a. Okay. Now see, both are log terms and the bases of both of the terms are a, same base, log is there. So we'll comparing both the sides, we can say that y is equal to x. Why so? Because you remember in the early, in the small standards we used to learn that if 2x is equal to 2 raised to 3, now these bases are same, so x is equal to 3. We used to do this. Okay. So in the same way, log of y to the base a is equal to log of x to the base a, then it is but obvious that y is equal to x. Now y is equal to x, but what is your y? Your y is your LHS. Okay, and what is your LHS? Your LHS is a log x, sorry, LHS is a raised to log x to the base a, and it is equal to x, hence proved. Because y is equal to what? It is a raised to log x to the base a. So what is the basic idea? That when you have a number who has an exponent of log with the same base, then the answer would be the domain of that exponent. For example, if you are given that 5 raised to log 5 to the log 8 to the base 5, then your answer would be 8. When these two numbers are same and there is a exponent of log, then this domain would be the answer. For example, if you are given m raised to log n to the base m, your answer would be n. If you are given that, suppose 25 raised to log say m to the base 25, then your answer would be n. In short, these two numbers should match. Exponent should have a log function, then this domain number will be your answer. So what is the common or empirical result? That log a to the a raised to log x to the base a is always equal to x. Okay, and we have proven this in this way. Thank you.